Cool. All right, let me share. All right, who we got on? So we got France, Emery, Alana, Baron, Fabiola. Zoom user is Aaron. Okay, Aaron. Okay. Lauren, David, Antonio, and the other Lauren, Miss Smallwood. Okay, gotcha. All right, let's get started. So let's share my screen. Okay. Everyone sees my screen, right?
Mm-hmm.
Okay.
No, we don't.
Oh, you don't see it? Okay. Give me 1 second. Share screen. Okay. All right. You should see it now, right? Still no?
Yes, I see it.
Yes.
Okay. All right. Okay. All right. So today once this freaking loads, today we're going to learn about our networking appliances and devices, right? Very essential in cybersecurity, very essential in networking, because what we want to do is get data to the correct places, right? But there must be steps in between, and there must be devices in between to carry those data packages where they need to go, the destinations, all right? So the first thing, right? Network appliances are specialized devices designed to manage, optimize, and secure network traffic. Okay. So when you're on your phone, when you're on your tablet, when you're on your computer, okay, when you're watching TV, network packets are constantly going between your device and the origin server or another device, right? Packets are going through the internet. And within those packets, there's information, right? There's information to give you the exact data or the exact image that pops up on your screen or your phone or your tablet. Okay. So they play a crucial role in ensuring effective communication within computer networks. Okay. There's different types of data delivery, right? TCP, right? We have TCP, we have UDP. One sends data in a fashion where it's organized, and another sends data in a fashion where it's unorganized. Hey, we're worried about just getting the packets really quickly. All right. So, understanding these devices is essential for anyone involved in network administration, IT, and cybersecurity. In general, right? You want to know about networking devices. So here are a few of our networking devices. We have switches, hubs, multi-layer switches, firewalls, modems, repeaters, bridges, and routers. Okay, we won't really see repeaters anymore because those are very old. We won't even see bridges anymore, right? We may see a modem that acts as a router, or we may just see a router. Okay, so here are our types of networking appliances, right? So there are several types. Again, we talked about routers, we talked about switches, firewalls, load balancers, and each of them really have a distinct purpose, right? Some may carry information to another computer, some may bridge two networks together, all right? Some may distribute traffic and make sure the traffic does not overload the network, right? So those are load balancers, right? But let's take a deeper look into this, right? So routers. Okay, so routers are devices that forward data packets between computer networks. All right, that's what a router is, right? Networking 101. The router forwards the data packets between computer networks, right? They connect multiple networks and direct traffic using IP addresses, right? So, for example, if we see some IP addresses, right? I'm just going to use the whiteboard real quick, right? An IP address could be this, right? This could be an IP address. When we have like, let's say, let's give you an example, quick example. 1 dot, oh, that's not good. So this could be an IP address like, 8.8.8.8. Okay, that's a server IP address, right? But maybe IP address could be like 192.8. I don't know, 10, something like that, right? This is an example of an IP address. All right. And is anyone familiar with like IP addresses or seen them before?
Yes.
Okay.
Yes.
What did you say the first
work
one
with them all
was
the
an
time.
example of again?
This is like a server IP address. This is like not a common IP address. So
Mhm.
for example, 8.8.8.8 is the server to Google, right? Sometimes a lot of people will test their network connection by
Mhm.
pinging, right, this IP address, right? So 8.8.8.8. If you want to figure if your network's up, you can type in PING 8.8.8.8 and try to ping that in your command line, right? The command line is basically that screen where it's all black and white numbers, etc. And you can run, those codes or those pre-installed, commands on there. Okay.
Okay.
But yeah, this right here, let's say 192.8. Let's say .10, right, would be an example of a IP address. Okay.
Okay.
All right. So let's go back to the presentation. So if we go back down, routers are devices, right? Simply what we want to understand that routers are devices that connect different networks and different data between them using IP addresses that ensure information reaches the right direction, all right? So they're essential for linking home or office networks to the internet. That's what it does, all right?
We can't
Now,
see your screen.
oh, you can't see it?
Mm-mm.
Okay, apologies. You have to remember to go back and forth. I like it on the iPad because I can use this little pen thing, but I need to make sure that I share. All right. So the next thing we have are switches. All right. So switches are responsible for connecting devices within the same network. Okay. So they operate at the data link layer and use MAC addresses to forward data. All right. Now you think of a MAC address, right? Think of a MAC address as a dog tag or, a tattoo for your computer or your iPhone or any device, right? It is a device identifier, right? So each device has a special MAC address associated with it, right? So once the MAC address is there, the data goes to the device depending on the MAC address, right? So I'll show you an example of a MAC address. When I go to the whiteboard. Okay. Okay, so if we go up, this is an example of a switch, right? So you have your switch in the middle, and let's say this is laptop A, laptop B, C, and D, right? So A wants to talk to B, right? The information will go to that switch, and then the information will go to B, right? B wants to talk to C, the information will go from B into the switch into D, right? And so on, right? So at a basic level, that's what a switch is, right? Very, very old fashioned, right? When computer networks were just getting started, right? And that is something that is foundational to networking, okay? So knowing what a switch is very good for you to know on that exam, right? And then we have firewalls, okay? So I'm sure most people heard about firewalls, right? But can anyone sum up what a firewall is in their own words? It doesn't have to be perfect, but tell the class what a firewall is without looking at this. Yeah. What's a firewall?
Wouldn't it be like a gate? Like
So
check-in point, I
Mm,
would say.
mhm.
You know, you have the pass, and they'll let you through. If you don't have a pass, they stop you right there.
yeah,
Yes, that's a
yeah.
good
So
analogy. Mhm.
I agree with that. It's like an automatic wall that stops unsuspicious applications from starting in the first place
Mhm.
sometimes. Mhm.
Absolutely. Absolutely. All on point, right? But let's refine that, right? It is, to me, the best example I tell people is like a security guard, right? Before you can get into the club, you have to give your ID to prove yourself, and you have to get pat down to get into the club or get into the bar, etc. Right? So if we look at the essence of a firewall, right? Firewalls are security devices that monitor and control incoming and outgoing network. Okay, so they can be hardware based, or most of them are software based, right? And or they could be a combination of both, right? But if we go back to this example right here, right? Firewalls protect networks from unauthorized access and threats by enforcing security policies, right? So, like we said, hey, we're not accepting any traffic from the internet. So, what we're going to do is disable port 80, and no port 80 traffic will be coming through in and out our network. Okay. Or let's just say, hey, let's make up the protocol for Zoom, right? But let's say, hey, we want to block Zoom traffic. So Zoom traffic could be like port 3,800. Okay, you're not gonna need to know like ports past. Sorry, I have to mute somebody. Is that me? Who's there? Sorry, but I need to mute you. You're not gonna have to know ports past 30, right? But as far as a number, right? But um, firewalls are really there just to help you understand that, hey, we control the traffic that's in our network, okay? So that is what it's used for, all right? So another example with the club, right? It can be specialized. They can say, hey, you know, we need your ID before you come in, and we need to pat you down. But here's another caveat, right? You need to be over the age of 25 to get in the club. Okay. Here's another example, right? We need to pat you down. We need to see your ID, and you need to be over 25, and you need to be a member of this club or bar, right? So that is just a good example of, hey, how does firewall work, right? We allow in what we want, or we make up the rules, right? And that's why we call them firewall rules. Okay. The next thing.
Okay, really quick.
Uh-huh.
So what's the difference between like a firewall and like the way a VPN functions?
Okay, so a firewall is going to allow certain traffic on the network, right? That's just dealing with traffic. A VPN is going to be an appliance that you use to forward you to company resources, that may be, you know, on a remote server. So, for an example, if you go to Russia,
I mean like personal ones. Like I'm talking. I mean cut you off, but like not corporate ones. But I mean like IP VPN or whatever. Like
Yeah.
Surfshark or something like that. Those services.
oh, okay, personal
Like,
ones.
Yeah, yeah.
Yeah. That VPN is going to allow you to roam the internet, right, without really revealing your place of origin, right? So same thing with work, right? And the difference between work and the personal one is one costs more and one is just an enterprise solution, right? Personal deals with maybe like, I don't know, like 5 or 10 people in the house, right? But it's going to conceal your identity or conceal where your origin of, of requests have came from, right? So
Mhm.
that, people can't track you or go back to your home network, etc.
If I may input a little bit.
Yes, sir.
So like also for like the VPN is like a there's also very similar to like a proxy server you may hear. VPNs and proxy are kind of like the same thing, but it's like a virtual network basically. So it's a virtual IP. So like if you get IP banned on one IP, you can use a VPN and so access the network because you're basically showing up that hey, I'm actually a different person or a different computer. You can show that you're in a different country
Mm,
or a different state,
yeah,
just off of
yeah,
your VPN.
yeah, yeah. Essentially, like even here in Bermuda, right? A lot of like Netflix, Hulu isn't available, right? Unfortunately. So a lot of Bermudians may go on VPNs to access, Netflix or Hulu and say, hey, you know what? I'm actually located in the United States or located in Canada.
hmm
So,
hmm
that's how we
Yeah.
get the access.
Even more
Yeah.
serious than that, like I think in countries like North Korea, where they don't have access to like Google, they have their own like stuff that's like very protected. They can only see certain information. So the only
Mm,
way they can even get certain information is using VPNs to, you know, be not on a North Korean IP address.
hmm Yeah, absolutely.
Thank you.
All right.
Question.
Mhm.
Since we're talking about VPNs, so how does the company recognize if the VPN is supposed to hide your origin? How does the company, for example, like Netflix, determine that you're actually using a VPN?
Yeah, that's a good question. I'm not actually sure about that. I'm thinking at the end of the day, your VPN is coming from a country that's not on the blacklist, right? Or a country that Netflix, is the IP address. I'm sorry, the IP address is coming from countries they operate in, they do business in. So millions of IP addresses are accessing Netflix's server, right? And they have a block and allow list, right? That says, hey, IP addresses from this country are allowed and IP addresses from this country are denied, right? So I can look more into your question, right? But
If I may
that's
input a
how I'm
little bit
thinking
too on
about
that.
it. Go ahead.
So yeah, that is a good question because I also wonder the same stuff. So like I know it's very hard per se if like your question is how do you catch someone using a VPN? It's more of there's other ways you can catch them, such as if they visit your site before, they may have cookies, or maybe they didn't change their, I don't know, maybe the MAC address, but there's like specific device information that unless you remember to change that, then like they may be able to find you another way. But usually if you're changing your VPN, it's hard for them to know.
Yeah. Um, to add to that, really is just if Netflix started getting strict with IP addresses, then they could probably find you, right? But yeah, they want to be more liberal and say, hey, everyone stream our services. If that was the case, nobody would use Netflix if people were getting banned. But okay, let me move on to the next session. All right. So load balancers. Okay. So load balancers distribute network traffic across multiple servers to ensure reliability. Okay. They optimize resource use, they minimize response time and prevent overload on any single server. Right. So basically with load balancing, what you're thinking about is, hey, if we have, let's say 1 million requests come in at one time, right? It's possible, right? And they want to access Netflix server. Well, those 1 million requests, if Netflix just had one server, if Netflix just had a single server, Netflix would not be Netflix today. Netflix was shut down. I think we saw it when I think Mike Tyson fought what's the guy's name? Jake Paul. The Netflix servers kept rendering. Okay. It may be because, hey, so many people were accessing Netflix at one time, right? So we're talking about an influx of requests, right, coming to one server, right? So in that case, we use load balancers. Okay. Load balancers is exactly what the title says, right? We are balancing the load of users or requests to different servers so they can, to different load balancers to access our servers, right? So if we go to our whiteboard and we click whiteboard, let's just say whiteboard. All right, so we're on a whiteboard now. And we're looking at load balancers, okay? So, internet, right? Hey, you know what? I'm trying to watch this Mike Tyson fight, this Jake Paul Mike Tyson fight, right? On Netflix. We're all coming from the internet and we're all coming to these load balancers, right? Because they have it set up this way. These load balancers are going to fill up, right? They're going to fill up. They're going to fill up with requests, and then they're going to be spread through the Netflix servers, right? So they're saying, hey, you know what? I think you have, 2 million people accessing this server. All right, we're going to disperse the load onto server 2, right? And then, you know what? It's too many people on server 2. We're going to push it on server 1. Or sometimes they can say, hey, you know what? I think that server 3 can be a specific region. Like all the internet requests coming from South Africa can go to this server. All the internet requests from London can go to number 2. And all the internet requests from America can go to server 1, right? This is what load balancers do, all right? So if we didn't have any load balancers, right? And imagine all of this traffic, right, went to server 1, right? What's going to happen if we didn't have these load balancers in place? You can say it out loud.
The crash.
Yep, this will be no more, right? So it is essential that we have load balancers. For an example, some of our past cohort students, they took the Security Plus exam. Like some of them took it basically the last day, where there was, when you take it the last day, sometimes these exam publications, they expire, right? So 601 expired in July of 2024, right? July 31st. And people were scrambling to take that exam. Why? Because they probably studied for the content that was in 601, right? We're on Security Plus 701 now, right? And that's going to be valid for maybe 4 more years, right? But when people went to go take their exam, we had people from all over the world, right? And the exam provider, right? They are called Pearson VUE, right? I believe Pearson VUE makes books and all that good stuff as well. But Pearson VUE, you go and take your most of your tech exams on that website, right? Pearson, yeah, Pearson. That's exactly how you spell it. Pearson VUE, Pearson VUE. So basically, when people went to take their exams on Pearson VUE, they all did at one time, right? So you had millions of traffic from all over the world trying to take the Security Plus exam on the last day. And right, you know what happened? What happened, y'all? Everyone tried to take their exam on the last day, and what happened? Crash. The whole thing went blah, kaput, right? People paid, the $400 for the test voucher, and people have been preparing for it for a month, for 2 weeks, and they're like refreshing and reloading, and you're like, yo, what's going on? Or I'm in the middle of an exam, like what's up? And you're like, dag, like what if I don't get into this exam anymore? And they, um, they fail me, right? But what happened was Pearson VUE refunded everyone, and from there on, they said, "Hey, your exam voucher is valid for 1 year," right? But that is, if you don't have a cybersecurity risk management process or something to talk about, that can happen, right? It's simple for someone to say, "Hey, you know what? There's going to be an increased traffic on this day. okay? Or you have instances like Black Friday. You know everyone is going to flock to your website. Hey, maybe we should spin up 4 or 5 load balancers so we don't exhaust our servers, right? So I hope those examples help. Anybody have any questions before we move on? Okay.
Hey, Deontay, really quick.
What's up?
Is that the function of a data center to kind of help balance that too, or no?
Yeah, in some instance. So if we're using, like, let's say we're using AWS, Oracle, or Google Cloud, the data center should have the infrastructure to make sure that doesn't happen, make sure those crashes don't happen, right? So maybe Pearson VUE was going through AWS, Amazon Web Services, and at the same time, it's up to the cloud engineer to make sure they have enough load balancers, right? AWS, Azure, Google Cloud, they have enough of those. You can probably spin up 1 million if you wanted to, right? It's probably going to cost you $1 billion, but you have to spin up as much as you anticipate, or you have to have it. You can automatically let it scale, right? It can scale on its own. So, if you have a rush or people are coming to your network at, your website, your servers, all at once, you can configure it where it automatically scales based on the traffic, right? So that was most likely the fault on the engineer, right? But if you really want to get deep, that's probably the fault of leadership, right? Whoever their manager was, right? Whoever the planning committee was. So, all right. Access points, right? So access points extend a wired network by adding wireless capability. Okay. So they allow wireless devices to connect to the wired network seamlessly, right? So modern access points support multiple standards like Wi-Fi 5, Wi-Fi 6 for enhanced performance. Okay. So those access points are going to really help people get on those networks. It's also going to give wireless capability, right? So wireless devices can be connected to that wired network, right? The wired network works with, a lot of cords. Those blue cords that you see a lot of times, right? Those are going to be more so your wireless LAN networks, right? And access points are going to give those wireless machines that are not connected by cable access to the Wi-Fi or the network. Okay, so those are going to be access points. The next thing we're going to learn about is a NAS, right? Network attached storage. All right. So NAS devices provide centralized data storage accessible over the network. Okay. So this is just data, right? A data storage accessible over a network, right? It can be an internal network or a public network, right? And it's very ideal for file sharing, right? We have file sharing, backups, media streaming, and they include redundancy and security features, right? So you see all these laptops around here, right? And that wall is going to be a network attached storage, right? So in our internal network, in our internal group, we have a network attached storage where we, submit files for presentations, or, we submit photos of, company dinners, etc. Right? This is our own little personal network, okay? And it's shared just between me and Alana, or me and Shar and Alana, or me and David, right? So that is going to be network attached storage.
Is it like OneDrive and Google Drive, things like that?
Yeah,
Or
sort
like
of.
Dropbox?
Yeah, kinda. But just the difference between that is that Google Drive, OneDrive, Google Cloud, those are going to be cloud-based storage, right? Network-based storage is just in our internal network. It does not leave the network at all, right? So that's what it is. It's closed off to the internet. All right.
Okay, thank you.
No problem. Let me know if you need me to explain that further, and I can do that. So, modems. So, give me a thumbs up if you seen a modem before. I'm gonna look in the chat. Okay. Modem. Yep. Okay. People have seen modems. Okay. Good. All right. So you look at your modem, right? Modems basically convert digital signals, digital signals from a computer into analog signals for transmission over phone lines, right? This was the early use of a modem, right? So they're essential for connecting the internet through broadband and DSL, right? Something that we really don't do now, all right? So modems, modern modems often come with built-in router capabilities, right? So sometimes you get modems from like maybe Verizon or Comcast, Xfinity, right? And they're going to basically be used for router capabilities. Okay. So these are very prevalent in homes. If you have the Wi-Fi set up, right, you may have a modem as well, right? But that's basically what they're used for, right? You really get them from telecom companies as well. As we see here, we have some telecom companies like a Nighthawk, Eris, etc. Right? And then we have gateways, right? So gateways serve as a gate between two networks, often with different protocols, right? So they perform protocol conversions to allow communication between different systems, and gateways often include features like firewall, proxies, etc. So here in this picture, we have two different networks, right? And the gateway in the middle, right? And down here, we have the switch that are connecting to all the PCs, right? And basically what this gateway is allowing is data sharing from this network to the right to come over to share data to the network on the left, right? So it's really creating a bridge, honestly. And that bridge is essential for information sharing, right? Maybe it's a company or maybe it's an office, right? And that office wants to share information between each other, right? So that is what a gateway is, just exactly how the word says gateway, right? Let's connect these two and make a bridge between each other, right? VPNs. All right. So we have VPNs, right? And excuse me. We'll go back now. VPNs provide secure remote access to a network over the internet. Okay. So the good thing about VPN is encryption, right? So any data that's coming from your remote location, right, through the secure VPN to the network access server to the main office, right, that traffic is going to be encrypted. So remember what we said about encryption is that when something's encrypted, right, it's taking plain text and scrambling up into ciphertext, right? So ciphertext is text that is scrambled up. It could be a series of letters and numbers, special characters, right? And when it's going through that secure VPN tunnel, right, people are not able to intercept, right? And if they do intercept the message, right, the message is not readable, okay? So say that, hey, you're at your remote location in the house and, you know, um, you want to access OneDrive, right, uh, at the main office, right? So your OneDrive request will go from your remote location through the internet to the office, right? And in that packet, right, in that single packet or those few packets, it will say, OneDrive login, OneDrive password as you're going through the OneDrive, uh, the OneDrive homepage, right? And what encryption is going to do is going to take that and it's going to jumble it up, right? So even if an attacker intercepts your connection to OneDrive to the main office, they will not be able to make out what you're doing, right? If they intercept that package, right? And that's what the VPN is there for, right? It just think of it as protection, right? Protection, and you're going through a tunnel, and no one's able to see what you're doing, right? So it's good for privacy, good for encryption, etc., right? And the reason why organizations have this is because, yes, corporate espionage is something that is real, right? Other companies hire people, right? It's not, it's not correct, right? And it's bad business practices, but other companies can hire people to intercept traffic from one company, right? Or another company, right? Hey, let's see what AI models they're using by, listening in on their VPN traffic, or seeing what their traffic is on their networks. Hey, let's see what type of clients they're working with, right? Let's try to look at the employees' website traffic through the VPN tunnel, right? And hey, maybe we saw the employee going on Deloitte's website and going to a certain homepage, right? So this is why we have VPNs, right? We want to securely remote access into a network, right, over the internet.
Question.
Yes.
So do you have to request a VPN, or is it just something that happens? Like Lauren says, I use VPN if I'm at home, but need to print something at the office. Like if I try to print something from here to my office, does it just automatically happen, or do I need to request a VPN?
Yeah, so usually if you're on your work laptop, they install the VPNs.
Yeah, mine's is like installed, so I know to go to it. And like if I hit print, it would give me an error. Like I would need to be like connected to it in order to print.
Mm-hmm. Absolutely. Yep. Yeah, they'll
Okay.
install it. IT, when you get your company laptops, that's like first order of business.
Mhm.
Most companies, everywhere you go, they use something called an image, right? Image, IMAGE, right? And an image will have already preloaded programs on the laptop, right? Once they load the operating system, and they'll load it with, let's just say, what's a VPN most companies use? Let's just say Zscaler. I think Zscaler is a VPN. Let's just say Zscaler, and it comes with Adobe and I don't know, Cisco, Fortinet. Yeah, Fortinet is a VPN, but it'll come up with preloaded programs, and then you'll be able to do what you need to do, right? As long as it's on the work laptop, right? If you try to access, your company's intranet or your company's resource that you normally can't access, you'll probably get an error or say, undeliverable. Okay. So make sense, Sharp?
Yes, thank y'all so much.
No problem. No problem. All right. Intrusion detection devices or systems. All right. So an IDS devices monitor network traffic for suspicious activities and potential threats. Right. So they can alert administrators about possible breaches or anomalous behavior. Right. IDSs can be configured to take action automatically or provide reports for analysis. Right. So let's go to the whiteboard real quick. The handy
That's me.
whiteboard. Okay. So think about an IPS as like I want to say like a detection dog, right? So let's just say I'm gonna write some of this. Let's just say we have an environment, right? We have let me see if I did it over here. Okay, no. Okay, let's say we have an environment, and we have, you know, we have a laptop. We have a laptop here. We have a laptop right here. And let's say, I don't know, we have a mobile phone, right? I don't know. What else can we have? Database here. This is our database. And I don't know what else. Let's say firewall is going to be right here. This is going to be the firewall. Okay. Yeah, this is going to be. Oh, come on, pen. Those things running out of batteries. All right. So we have our firewall. This is going to be fire. All right. No, don't judge. Make this fire. Okay. What your IPS device is going to do is it is going to be right after this firewall, right? Let's just say this is our IPS device, right? It is going to look at traffic and it's going to say, this traffic kind of seems suspicious, right? This traffic is coming from a country that is on a blacklist, or this traffic is coming from, you know, a website that employees maybe should not be looking at, right? And your IP address is going, your IPS is going to, is either going to send the cybersecurity analyst a message, right? Or alert, right? And that alert could be, hey, suspicious traffic, okay? So all I really want you to know is that those IPSs, right, is really just a machine that is used, a network appliance, just to say that, hey, you know what? This traffic does not look normal, right? We're going to investigate that. And that's really what it is, okay? So just remember you have your firewall right here and then your IPS machine, right? So as you see on this mini network, we're starting to add appliances, right? We're starting to add network devices, right? And just remember that, hey, you know, we have our computers in here. We have our database. We have our phone. I don't know. That phone looks like a Pop-Tart. So I'm sorry for that. It's not the best looking phone. But it's going to process traffic and say, hey, cybersecurity engineer, you know what? We've seen some suspicious traffic. And I'm not messing with it. I think you should do something. Or, you know, an employee was going onto a site they shouldn't have gone to, and it brought back trouble. Okay. So that's what you want to understand for this specific example. Okay. Any questions on that?
Yes, I have a question.
Okay.
Can you, for the IDS, does it monitor outgoing or ingoing traffic? I'm trying to understand, does it,
Both.
because the request
Yeah,
comes
most
from
of these machines monitor both. Oh, can you hear me?
Yeah, I hear you.
Okay. Oh, I'm sorry. I have my video off. Most of these appliances monitor incoming and outgoing traffic. Okay. So incoming traffic coming from the internet through the firewall, through the network, right? Now, if it's something that is unfamiliar to the IPS, they're going to flag it and they probably will deny the traffic, right? If it's something familiar coming in the network, it's going to let it go to wherever destination it needs to go, right? Also, like, hey, say if it's like an employee laptop, right, and they're sending out, you know, like malicious scripts or anything that looks sus, right? That IPS is going to look at the traffic coming from your laptop, my laptop, and kind of judge it, right? And say, hey, you know what? This sounds like it's malicious, right? So it does work both ways, right? So
Thank you.
yeah, no problem. All right. As we go back, I think I need to share again. All right. So what's the next thing? To be honest with y'all, I'm not a fan of the iPad, but I like using the whiteboard. So I may have to find another solution. Okay. Networking monitoring tools, right? So network monitoring tools track the performance and health of a network. They provide insights into bandwidth usage, uptime, fault detection, right? And effective monitoring is essential proactive for network management, right? So this is like a network monitoring tool, something called Wireshark. And I really will go through it real quick. You'll have some experience with that, right? But for Wireshark, I'm gonna just quickly break it down. In this example, you have the source IP address, that 192.168.0.21, right? And then the destination is 174.129.249.228. All right. So these are actual packets that are going from and to a destination, right, throughout our network, right? And you'll see the protocol, right? We'll learn about protocols as we go in the book and the chapters, right? But in here, right, in the protocol, right, for example, let's do this protocol right here. Let's say line 349, you see on the left, right here, on the far left, it is kind of highlighted in like a dark bluish purple or a dark grayish. Number 349, right? The destination IP address is the source IP address is 192.168.0.1, right? That's could be somebody's laptop, right? They are going to one of Netflix's server, right? The Netflix server, the source IP address is 192.168.0.21, right? And they're using the DNS protocol, okay? You can tell it's Netflix because in the packet, right, you see CNAME images.netflix.com, right? Most likely they probably scrolled on a movie title, right? And the packet came back as images.netflix.com, right? Because you can't click on images on netflix.com. I don't think so, right? The only thing you can do is take your remote and put the pointer on a title, right? But in the packet comes back that, hey, you're on an image, right? Does that make sense to everyone? Is that kind of, sort of? Let me know, because I can't see the chat.
Yeah.
Okay.
Yes, it does.
Okay. Cool. So this is how people analyze traffic, right? Right. This is how people analyze packets. So you can look at this. You can really spy on somebody's traffic if you have Wireshark and you know their IP address or anything like that. So say you know, I mean, this sounds really creepy, but you know, if you are on your network and you want to see your brother or sister's browsing habits, you can install Wireshark on on your laptop, and everyone who's connected to your network, you can see what website they're looking at. All right, you didn't hear that from me, but this is essentially what Wireshark is, right? You can monitor the network. All right. But this is good for cybersecurity analysts, even SOC analysts to see, hey, where is this, network traffic originating from? What server is it coming from, et cetera, so we can actively track it down. And once we track it down, we can just block it, or we can do a further investigation. All right. Power.
Quick question.
Uh-huh.
Before you blocked it, wouldn't you quarantine it first just to make sure it wasn't affecting anything else?
I mean, yeah, you can do that, right? If you are, an IT engineer and you're taking the correct steps, that would be the smart thing to do, right? Instead of, ultimately ruling it out, you want to go and investigate it, right? And see where it's coming from, because maybe you're kicking off an employee that needs that resource, right? But you can investigate it before you kick it off the network. But just for an example's sake, I just said that, hey, maybe you just boot it off. All right.
Okay, makes sense.
No problem. And that was a good question, because on the test they may ask you that. They may say, hey, we've seen some network traffic coming from an unrecognized IP address. What is the first thing you do, right? And sometimes they'll have the answers like, hey, kick it off the network, or see if it matches up with any internal IP addresses and investigate, or just let it do nothing, right? Those are the questions they'll ask you on the exam. So that was a good question. All right. Next is power over Ethernet devices, right? And this is a very simple concept, right? Power over Ethernet is technologies that allows network cables to deliver both data and power devices, right? So this simplifies installation by reducing the need for additional power outlets. And common power Ethernet devices include IP cameras, right? So if you have cameras connected to your house or your shop or anything like that, phones or wireless access points, right? So your Android or your iPhone charging cord is usually a power over Ethernet device, right? So you can plug it in, and it can charge the phone at the same time, and then also get data, etc. Right? So that is power over Ethernet. Also, if you see, I forget what those blue cords are called. I'm like blanking on that, but if you plug in a cord to a router, to a switch, and then plug it to RJ5. Yeah, thank you. Your RJ5. I've been out of help desk for a long time, so thank you, because I was blanking. So if you have your RJ5 cord, you can connect it to the switch, and when you connect it to the switch, if it's a power over Ethernet cord, it can provide power to the laptop, to the device, and then provide data as well, right? So that is something that we see in the field. What's next? Okay, performance optimization appliances, right? So these are appliances that enhance the speed and efficiency of network traffic, right? So this includes WAN optimization, so wireless wide area network optimization, right? If we have a big network, right, and it can help with application accelerations and caching solutions, right? Caching is stored memory, right? So you can access something quickly, right? Instead of having it load, right, it can be cached, so you can access it at a drop of a dime, right? So for example, if you have a website, a web page cache, right, and you just don't have any internet connection, or the last time you accessed the site was maybe like 2 hours ago, that cache is going to bring the information or save the information for you, so you can have the data, right, until it updates, right? So that is a caching solution. Other caching solutions have data that is stored closer to you, So then, you can retrieve your resource faster. For an example, say you're in Australia, right? And no, that's a bad example. Say you're in London, right? And you want to access a movie on Netflix, right? I use Netflix a lot as an example, but a cache Netflix server will be a server that could be closer to, Netflix in California, wherever their main servers are. I'm not sure if it's in, um, I forget what town it is called where Netflix is located, but you can have a cache server that's maybe, located in Mumbai or located, um, I don't know, in New York to get to those Netflix servers, right? That's what caching does, right? It brings the information closer to your area or your source of origination, right? But in terms of performance optimization appliances, right, they're going to basically help a network move quicker, right? If you need to access apps or if you need to access resources, right, those optimization appliances are going to speed up the process, right? Instead of 2 seconds, it goes down to 1 second, right? And furthermore, etc. Right? So that is going to be performance optimization appliances. And then we have unified threat management, right? So unified threat management appliances integrate multiple security features into a single device, right? So it could typically include firewalls, antivirus, intrusion detection, and content filtering, right? So basically one device with many uses, right? It has firewalls installed into it, right? It has antivirus, right? It has intrusion detection, it has content filtering, right? So UTM solutions simplify security management, right? That is all it's doing, right? Instead of having all of these things spun up, all these servers, all these firewalls, all these IDSs and IPSs, we have a UTM that aggregates everything in one location and it does what it needs to do. All right. We're almost done. Software defined networking, right? SDN devices. So SDN devices allow for more flexible and programmable network management. Okay. So they separate the control plane from the data plane, which you'll learn in the class next week. And they enable centralized network control, right? So SDN is increasingly popular in data centers and large enterprise network, right? So if you think like movies where you see action movies and they have that big old screen and they're looking at all the data and all the threats and all that good stuff, right? Think of software defined networking, right? We call it a single pane of glass, right? We're looking at all the networks, right? Another example is like, you see those NASA control rooms where everyone is all looking at one screen. Yeah, basically software defined networking. All right. So what are the future trends in networking appliances? Well, the networking appliances landscape is evolving, right? And one thing you know about cybersecurity that when they say things are advancing, that just means AI, right? So a lot of this will be AI functioning, right? That is the reason why we implemented AI in our course, and that's the reason why we say, hey, AI is going to be a big feature when getting into cybersecurity. They're going to like people who are in AI more than people who are already, at the company and they just know about cybersecurity and that's it, right? Jobs are looking for people who are fresh, who are malleable, people who they can mold, right? So knowing AI and what to use AI for is essential, right? It's very essential. And then for our last thing, we're just going to watch this video and then we'll be done.
In recent years, software-defined networking, or SDN, has emerged as the next big thing in the networking industry. Given all the hype, where are we now? Researchers at Stanford are credited with creating the idea of bringing the tenets of virtualization to networking, and thus creating the software-defined networking market. Traditional networking uses integrated hardware and software to direct traffic across a series of routers and switches. The original use case for SDN was to virtualize the network by separating the control plane that manages the network from the data plane where traffic flows. There is a smart controller running specialized software that manages all network traffic in the data center, and a series of routers and switches that forward packets of traffic. Virtualizing the network comes with advantages. Networks can be spun up and down dynamically, they can be fine-tuned for specific application use cases, and security policies can be installed on each individual network. Today, the SDN market has evolved, and it's breaking out of the data center. SDN is being used in the wide area network to control how enterprises connect to their branch offices. This use case, called SD-WAN, uses software to aggregate multiple types of network connections, such as broadband, MPLS, or wireless, to create strong and cost-effective connections. Micro-segmentation is the idea of using SDN for security. Certain networks can be ultra-secure and carry sensitive data. Other networks can be public-facing. So, if a hacker gets into a public-facing web server, they are restricted to the server segment of the network. This limits the hacker's ability to access any other segments, such as secure data center networks. SDN is also used in an area called Network Function Virtualization, or NFV. This is the idea of replacing specialized hardware like firewalls and load balancers with software running on off-the-shelf server hardware. Some vendors are using SDN to connect data centers to public cloud providers, creating a hybrid cloud network that includes microsegmentation or dynamic.
All right, let's go into the weeds, so I'm gonna stop it. All right.
I have a question. Actually, I have two questions. The first one, so it seems like when you were talking about switches and gateways, they almost kind of do the same thing, but do switches need gateways to operate?
No, they don't. They don't
Okay.
need gateways to operate, unless the computers in the network want to communicate to another network, right?
Mhm.
So remember again, those switches are going to pass data from one computer to another computer, or one asset to another asset, right? Those
Mhm.
gateways are going to bridge other networks together.
Okay.
No problem.
And the other question is, at the end of that video, when they were talking about micro segmentation, so I guess would a software example of that be like SharePoint? Is that an example?
Maybe. I'm not sure. I'm really not sure about micro segmentation.
Okay.
Because I would have to get that answer for you later.
Okay.
But if I'm looking at what it's talking about, it's talking about maybe if we have something in the cloud, how do we break it down more and more and more and more? That's what I think, but I can get a definite answer to you next class. Okay? No problem. All right. Anybody else have a question? That was the last thing. Go ahead.
Just this question on AI. I know there was an announcement about Biden about, I guess, AI chips, and they always tied to cybersecurity. What do you think in terms of like everything you've kind of gone over? Does that recent like his policy, does that impact anything in cybersecurity? Like, what's your interpretation of that in terms of opportunities? Does it keep more jobs in the United States related to it? You know, just the whole, and the other thing is from an AI perspective, right? It feels like AI has the opportunity to like create certain compromised, compromised cybersecurity, right? If it's done from offshore. So, I mean, does that impact the overall prospects in terms of like jobs in America?
Yeah. I can share with you. I'm gonna share with you this real quick, because
And I'm sorry if I asked that question succinctly. I was
no, you're good. You're good. I have a video I want to share with y'all. And it is I'm gonna load it up real quick, but essentially AI is taking over jobs. So yes, everyone believe the hype. AI is really taking over jobs. So I want to share this video with y'all real quick. It's on TikTok. I don't know if TikTok is even working. Is it working?
It still works.
Okay. Okay.
There was an interview that I watched today about some guy he's actually in Houston. I think he's like an AI expert. It's like a black dude, a
Okay.
brother. And I was actually gonna put in the chat, but I was gonna send it to you first.
Oh yeah, put it in the Discord.
Well, I was gonna make sure you cool. I don't know. I don't know the dude. You might know, you might not agree.
Oh, I mean, as
I'll
long
put it in
as
Discord
nothing
or something.
that's
But it was interesting. Yeah. It was
yeah,
an interview.
as long as it's nothing that like goes against our class policy.
No, it's not. No, it's not offensive, but you know.
Okay. Everyone see my screen?
Yes.
Okay.
It's just been released. Let me break it down for you. I'll go through the fastest growing jobs as well as the declining jobs and where all the gaps lie so that you can take advantage of it. It's been estimated by 2030, 92 million jobs will be displaced, but it will create 170 million jobs, so it will be a net gain of 78 million jobs. Now, these are the fastest growing jobs. We've got big data specialists, fintech engineers, machine and AI learning specialists. The fastest declining jobs are postal service clerks, bank tellers, data entry, cashiers, admin, printing, accounting, bookkeeping. These are the most important skills that you should be learning right now, and that is analytical thinking, resilience and flexibility, leadership, and creative thinking. Employers are looking to fill this gap by funding training. Now, the problem with getting all this training done is that 63% say that there's a skills gap in the market. So strategies of how they want to implement this is through upskilling the workforce. 85% want to do that. 73% of businesses want to accelerate the automation processes and tasks. And 70% of employers want to hire staff with those new skills already. And here are the countries that are very positive in hiring the talent that they need, which include
I'm gonna pause it right there. So these are a lot of the countries that are looking for people with these new skills. So what you heard was big data, artificial intelligence, or just automation in general, right? You can be an automation specialist if people need that, and AI and cybersecurity, right? But what you also saw was you needed analytical skills, leadership skills, and creative thinking skills, right? Because say what you want, being creative actually puts you in the place of being, your own boss, entrepreneur, right? You just come up with the idea and you have people work for you, right? But this is just an example of just the jobs that are affected by AI in the future.
include Egypt, Morocco, Bahrain, Saudi Arabia, UAE, and surprisingly, the countries that are not confident are Canada, Australia, USA, and UK. So, where is the gap in the market for all these opportunities? Number one, helping the workforce reskill. Because by 2030, 59% of the whole workforce will need to be retrained. And 63% of employees say that the skills gap is the biggest barrier to transforming their business. So this can include corporate training or e-learning. 2, AI and automation integration for small and medium businesses. They need skilled people or consultants to be able to advise them on how to implement this in their business or actually implement it for themselves. Number 3, getting talent. So businesses may have trouble getting the right people with the talents into their business. So recruiting, job boards, HR tech solutions may be able to do this a lot quicker. So with everything going on with AI and automations, do you feel confident in the next 5 years about your job? Let me know. The future of jobs.
So yes, that is the future of jobs, right? And we will have opportunities for y'all to come on board and help us train people, because we can't do it by ourselves, right? So we have those opportunities. I thought I saw someone's hand. Someone hands up.
I think that was mine.
Okay. All right. I got time for one more last question, and then I'll let y'all go for the night. Oh, well, what do y'all think about that? The state of jobs 2025. I see the look on your face, Shar. I see it.
So what I think about the fate of jobs is I'm happy that I'm in this class.
Mm-hmm.
A couple of years back, I was talking to a lady at Sam's Club, and I expressed to her about how AI would be taking over, and she just was like, I love to see that. Like she was like, like it would never happen, and then so I'm very grateful to be a little ahead of the curve.
Mm-hmm. Mm-hmm. Absolutely. Absolutely. Who else?
I guess I can give a little input. I guess I was thinking about how you're saying being creative, definitely has a lot of value in it when it comes to
Mm-hmm.
cybersecurity. Because like I'm also a very entrepreneur mindset. I run my own landscaping business, and
Mm-hmm.
um, definitely anything I can. I'm already trying to think of ideas of like anything I can try to do with AI. As far as businesses goes.
Mm-hmm.
Just a lot to think about for sure.
Certainly.
I mean, I would say I've worked. I mean, I started creating like AI bots like about 8 years ago when I
Mm-hmm.
worked at major tel. When I worked at Verizon for years,
Mm-hmm.
and that was like at the very onset of kind of like digital transformation initiatives. But when I think about AI, it's kind of like it's going to become such a common skill, and I think about some of the things I can do with like
Mm-hmm.
with Chat GPT. Like I created a whole process through a Chat GPT this morning that probably would have taken me weeks to do. So I think
Mm-hmm.
it's a matter of trying to figure out how you can actually just incorporate the skills to increase your performance because it's like
Mm-hmm.
steroids, right? It's like a PED.
Mm-hmm.
It's to the extent that you can use in your current job and then think about how it integrates for every aspect of basic functions. You got to do it because I'm telling you, everyone else is low key doing it. They're just not telling you. They're creating documents, job aids, processes, forms, all kind of stuff. And
Yeah.
so, and the other thing is the amount of money that we pay to outsource for AI solutions relative to the quality that we get. There's so much opportunity for people who have this, have a balance of skills and can create AI solutions for like larger
Mm-hmm.
firms who don't want to keep it in house. So I think that's really a ton of opportunity there.
Mm-hmm. Absolutely. Wholeheartedly agree with you. All right. Folks are using AI to jobs and telling you, don't use AI. You tell them, no, I'm going to use AI because why not?
And you know what
Right.
they look like.
Right. All right. Okay. So if that is it, I want y'all to enjoy your Friday nights. I believe, what time is it over there? It's like what, seven something in Houston?
8:50 in Philly.
8:50. Okay. It's 9 o'clock over here, so it's
Yeah,
9:49.
7:50 in Houston.
Okay, cool. Cool. I'll be back soon. But all right, if no more questions, I'll put that TikTok in the chat and then the recording should be good to go by tomorrow morning. Okay. And yes, great job today, everyone. Very, very good, great questions. Keep the questions rolling in. If something's not clear, just let me know, because we want to improve the best way we can. But yeah, man, I like that whiteboard setup. I just don't like switching back to record mode and share screen. So I'm gonna figure out some type of conduit or some type of thing to make it easier. Go ahead, Emery.
I was gonna say get an old Microsoft Surface. I'm telling you,
Yeah.
with the
Yeah.
detachable screen.
Oh yeah. I always thought this
I,
was cool.
that's on one right now. 7 years old. It still works better than any other laptop I got.
I always thought this was so cool. Yeah.
And you can draw it. I'm telling you, try it.
Yeah. Might look at it. All right. Is that it? All good? Y'all ready for your Friday night?
Yes. In a few, going to sleep.
Mine
Right.
it's already started snowing, so
Okay.
Netflix is.
Cool. All right, y'all.
Hey,
Well, have a good.
one last question. Just this kind of off
Okay.
topic. But I have a few friends that I've been talking about this course with about, and since the first week is pretty much coming to an end, for them to join this course specifically, like this time frame, is too late for them to kind of join, or is there anything that they could possibly do for them to start on Monday with us, or because I can send them your email, and that way you can have a conversation with them over the weekend and stuff. But I do have a couple friends that are interested in joining, and it works out with their schedule as well. It's just since it just got to this it's kind of, I don't know if it's too late for them or if it's, I mean,
have them send me an email, and then I'll give them a chat, and then we'll see about getting them in. All right, but they may have to pay
I mean, yeah, I mean, for
increased
instance,
price. Yeah.
yeah, that's fair.
Yeah. All right.
Yeah, that's all.
Okay. All right. Well, I'll let y'all have the rest of the night. Okay. It was really great seeing everybody today. I'll see y'all on Tuesday. Remember, no class on Monday.
All right. Have a good night.
All right. Have a good night.
Good night.
Happy
God
MLK.
bless everyone.
Good night, everyone.
What's up, my man?